Welcome to this new episode of Space. This episode will be looking at Jupiter's Jovian system and the goal of JUICE, a future mission of the European Space Agency. We'll discover exactly what's involved just after some space news in brief. NASA's Cassini spacecraft has begun sending its best-ever views of the northern extremes of Saturn's icy moon Enceladus, which is mostly covered by fresh and clean ice. Radio signals received by radio amateurs around the world have confirmed that AAU Sat-5 CubeSat is alive and kicking. The student-built small satellite was deployed from the International Space Station in October. The JUICE mission to explore Jupiter and its moons begins in 2022. To find out why this mission is so important, we came to the Paris Observatory. In Roman mythology, Jupiter was seen as the god of the sky, and it is, kind of. The biggest celestial body in the solar system has all the characteristics to be a king of our planetary system. The ESA's mission, JUICE, will provide the most comprehensive exploration of this giant planet and, in particular, of its moons, supposedly hiding habitable zones under their icy crusts.
Jupiter is a gaseous planet, meaning that if you try to descend into Jupiter's atmosphere, you wouldn't encounter, as on a terrestrial planet, a solid surface. Rather, you'd be in an increasingly thickening fluid.
What's intriguing for the astronomers is the specificity of the Jupiter satellite system and the vast oceans of liquid water underneath some of its moon's surfaces.
Jupiter itself is like a real planetary system with many satellites, in particular the 4 discovered by Galileo a little more than 4 centuries ago. These satellites are a world apart, each of them with a different geology. The mission JUICE will study them, at least the 3 furthest from Jupiter.
If the Jovian system can be seen as its own solar system to scale, Jupiter has missed its chance of being a shining star.
We refer to Jupiter as a mist or failed star because Jupiter is an intermediary between the Earth and the stars. She does not have sufficient mass to trigger the thermonuclear reactions that give a star its energy. She has hydrogen, but not sufficient temperatures to radiate like a star.
Understanding the Jovian system and its history, according to the JUICE project scientist Olivier Vittas, will give us better insights on how gas giant planets and their satellites form and evolve.
Jupiter is a planet of superlatives. It's the largest planet in the solar system, the biggest storm of the solar system, the largest moon system after Saturn's, and the largest magnetic field.
During its 3.5-year mission, JUICE will travel around the giant planet, studying its atmosphere and 3 of its planet-sized satellites, Ganymede, Europa, and Callisto.
If we find some oceans on Jupiter's moons, we'll be able to study if there are habitable environments that could harbour life.
Ahead of this, it will be necessary to travel through the solar system for nearly 8 years, and first of all, to safely exit Earth's gravity. This is one of the most risky moments in a space mission.
For me, the blast-off phase is the most critical one. We have to trust the launcher, which must be able to get away from the Earth's gravity and drive us on the right trajectory. At the end of the mission, we will put JUICE into orbit for the first time around one of the moons of Jupiter, Ganymede, the largest moon, and again, putting a satellite in orbit around a moon is something critical.
JUICE will perform several flybys of 3 of Jupiter's 4 main moons in order to unlock the secrets of the potential habitability of an outer solar system.
Europa and Ganymede are very, very big examples of the possibility of liquid water underneath the surface. The only thing that remains for us to find is how this water, how deep is it, how far is it from the surface, what is its extent, and if there could be life, living organisms originating in the liquid water within the underneath oceans on these icy moons.
JUICE will spend the main part of the mission around Ganymede, one of only 3 solid bodies in the solar system with a magnetic field.
Ganymede has the magnetic field and it is the largest satellite. If it possesses also liquid water underneath its surface, it is the place to go to look for life conditions, habitable conditions in the solar system besides our own planet.
This space mission requires years of patient work in dealing with the limits of our technology, which will be nearly out of date when the space probe begins sending back its first data. It'll be like receiving a call from the future.
A space mission is nearly a lifetime project, and we must be patient because data returns in a far distant time, 20 years or 25 years for some missions. By studying Jupiter more closely, we have access to some physical mechanisms which play a role in other planetary systems, which we hope will lead to a better understanding of exoplanetary systems.
Every space mission we make produces data for generations of astronomers to be working on them, as I did myself. And I'm hoping a lot of young people will now think about working on JUICE data decades from now.
And now our monthly meeting with Astronaut Academy. In December, the British astronaut Tim Peake will join the International Space Station. We went to the Astronaut Training Centre in Cologne to meet the man preparing him for the mission.
Hi, I'm Gerhard. I'm preparing currently the training for Tim Peake. Now I'm going to take you to the training hall where Tim spent many hours of his training. Welcome in the Columbus mock-up. This is the training model of the Columbus module. Tim is the specialist for this module, so I have to be engineer enough to understand really the structures they are operating. Total, he spent about 50 weeks in the US for training, about 30 weeks in Russia, and about 4 to 6 weeks here in Europe, and about 3 weeks in Japan. He knows everything by heart, and he's really keen to know every detail of what he is expected to do.
That's all for now. Next month, we'll discover how space technology helps to analyze climate change. Thank you for being with us, and goodbye.
E arrivederci.